All right. Well, welcome back. This is the second video on domain range and set builder notation and also restrictions and function notation. We're going to talk about restrictions this time. So restrictions appear in two forms. And so if I had a graph, we'll just do a quick sketch of a graph here. And suppose my graph had like a distinct starting point, like it started there and went in this direction. And now for those of you with a keen eye, you would recognize that maybe this graph of f is a radical function that's been translated somewhere. But let's not worry about the specifics about it. Let's just say there's a graph here and it starts at this point and it includes this point because there's a fixed closed dot, and it just grows up and infinitely off in that direction. So it'll cover the y-axis above here, and it'll cover the x-axis beyond here. So if I wanted to talk about the things that are restricted here, I need to talk about, okay, well, from the x perspective, everything from this line over in this direction is restricted. So there can be no values of x chosen from here. If I chose a value of like x1 over here, I would look up and I wouldn't find the function, and I would look down and I wouldn't find the function. I would say, okay, well, x1 is not in the domain of this particular function. So that must mean that it's been restricted. Now, there's a lot of x1s. In fact, all of these values out here are all restricted from the domain. So I call this a set restriction, because you're restricting an entire set of points, not just one specifically. So in a set restriction, you are often breaking one particular rule or a couple of different rules if you know more functions. So set restrictions arise when you're taking the square root of a negative number. So if you're taking the square root of a negative number, well, that's not possible. This is going to be restricted in the reals. Because we need the expression underneath to be positive. And so because we need the expression underneath to be positive, for this expression here to make any sense at all, we know that a has to be negative. And so for this expression to actually work and be calculable, we say that a has to be less than 0. And not just less than, because negative 0 is still just 0. So we can say it's less than or equal to 0. And so with radical functions like this, you end up with a restriction that's a set restriction. And on the graph, what it looks like is that it'll have a distinct starting point and it'll move off into a particular direction. And it'll ignore everything to the other side of its restriction. So this is saying a has to be less than or equal to 0. That would be a graph of maybe something that looks like this. Because it would go in, oh, actually, I'll just draw the exact graph. Because it would grow in that particular direction. So this graph's set restriction isn't everything on the left. Instead, it's everything on the right. Because if I go over here and look up and look down, I don't find myself landing on this curve of the function at all anywhere. So that's a set restriction.